Okay, given the functions f of x and g of x, find the value of each expression below. So I'm just going to jump right in because some of these are pretty quick and fast. F of 5, we're going to plug into the f of x function, which is x plus 4. So it'll be 5 plus 4. F of 5 will equal the square root of 9, which equals 3. So f of 5 equals 3. All right, that is that one. G of -1. I'll plug that into the equation. Don't forget to put parentheses around your -1. Otherwise, you will get some weird answers. Okay, and that looked weird too. So let me erase this, because this is supposed to be minus a -1. Okay, back to the pen. Minus a -1. All right, g of -1 equals 1 plus 1. So g of -1 will equal 2. Okay, then we'll go to finding x if f of x equals 10. So on this problem, all you're going to do is take your equation that f of x equals this and plug it in for f of x. So I'm going to say square root of x plus 4 equals 10, and then I'm going to solve. So I'm going to square both sides, and I'm going to subtract 4, so that's 96. Okay, that's pretty simple. That's what you do when you're given, when they give you the actual answer, the y value, the f of x value, then you just plug the function in for it. So the same thing happens on D. It says find it if g of x equals 6. So we're going to set x squared minus x equal to 6. Okay, first thing I'm going to do is move 6 over because I see this is in quadratic form. Okay, then I'm going to take and create my diamond, which I've shown you on multiple occasions. So I have to do my a times c and b. Well, a times c in this case because, let's see here, a equals 1, b equals -1, and c equals -6. So a times c is -6, b is -1. What two numbers multiply to a -6 add up to a -1? That would be a -3 and 2. So our parentheses, our factors, I should say, would be x minus 3 and x plus 2, which means x will equal 3, if I can get that to look like that, or x will equal -2, because it's whatever makes those parentheses evaluate to 0. So those are your answers for 1-119. Remember, if you've got any questions on any of these, put some questions in the comments and I will get back to you. All right, for 1-120, they want us to have the domain and range. They want us to state the domain and range. So I'm just going to go ahead and write D for domain range. And then on my domain and my range, I see this arrow here and it's heading towards -infinity for both. So I know I'm starting at -infinity on both, which means it can't be less than or equal to, it has to be less than, and then we have x and then we have y. Now, the change comes here on domain. I have this open circle here that goes to 6, and that means 6 is not part of the solution, but everything up to 6 is. So we say x is less than 6. We can't say x is less than or equal to 6. Now with range, it's a little different. The highest y value is right up here, and it looks like it's right at 6. So I would say y is less than or equal to 6, because that graph is actually hitting that point. Okay, and then we move to B. B looks like a cosine curve, but it could be a shifted sine curve as well. But for those, the domain is all real numbers. So -infinity, less than x, less than +infinity. Or you could just say all real numbers. And sometimes I just like to use that, all reals. All right, and then our range, it looks like it's hitting 2 points at -3 and then also +3. So our range is -3, less than or equal to y, which is less than or equal to +3. And that is the answer for 1-120. Okay, this one says, for each pair of equations below, determine where the graphs intersect. So what we're going to do is we're going to start showing it by algebraic method solving, and then we'll move and I'll show you the graph for each just to prove that we're correct, because you could also graph these to figure it out. So since both of these equal y, I'm going to set them equal to each other. So 3x plus 15 equals 3 minus 3x. I'm going to add 3x. Then I'm going to subtract 15. And then I'm going to divide by 6. So that means my x value is -2, and I can plug it into either equation to figure out what the y value is. So y equals 3 times -2 plus 15. Y equals -6. Oops, that's a 15. It's supposed to be. Sorry about that. -6 plus 15, which means y equals 9. So our point is -2, 9. Okay, let's take a look at the graph. Okay, so right here you can see where the intersection point is, and that's what we just solved for, and that is -2, 9. So let's move on to part B. Part B, again, they both equal y, so I'm going to set them equal to each other. And yes, it's a quadratic and a horizontal line, but this is the best way to do it. So, all right, equals 2. So I'm going to subtract 2 because this is quadratic form and set it equal to 0. So then what I have to do is my little diamond method here. And that's where I'm going to put a times c in the top and b in the bottom, which is -3. So two numbers that multiply to -10 add up to -3. That'd be -5 and 2. So I'm going to have x minus 5 times x plus 2 equals 0, which means x is equal to 5 and x is equal to -2. Now, the easy thing about this one is we already know the y because of this equation here. So we don't have to plug a value in and solve for y. We already know what it is. So our point will be 5, 2, and -2, 2. So let's take a look at that graph. So as you can see, when I bring in this graph, our points are 5, 2, and -2, 2. And those are the 2 points that we just solved for here. So that ends 1-121, and we're moving on. So on this particular problem, I'm going to go ahead and solve for the zeros algebraically just because I think we need some factoring progress or practice, I should say. And then we're going to talk about the domain and range and any special points such as the intercepts and vertex. The domain on a quadratic is all real numbers. The range has to do with whether it has a minimum or a maximum. This one will open upward, so it will have a minimum, but you'll see that in a moment. First, I want to just go ahead and solve. So I'm going to set f of x equal to 0, okay? And then I'm going to do my diamond method, which I've done a few times already. Well, my a times c in this case is -8, and my b is -2. So I need two numbers that multiply to -8 and add up to -2. So that's going to be -4 and 2. So that means my parentheses are going to be x minus 4 and x plus 2, which means my zeros, where it crosses the x-axis, are going to be at 4 and at -2. So now what we're going to do is we're going to go ahead and let this video talk about the rest of it. Here we go. On 1-122, they're asking us to find the domain and range and the intercepts and vertex for a specific function. So let's take a look at that equation by going to the y equals, and then we're going to plug it in. It's x squared minus 2x minus 8. And then we'll show you how to do this algebraically as well when we go back to the slide. But let's just get this down first. So I'm going to hit graph. And when I hit graph, it looks like it's crossing at -2 on x and 4 on the other x, on the other side, on the positive x-axis. It looks like it's coming down to about negative, let's see, 1, 2, 3, 4, 5, 6, 7, 8, probably about -9 it looks like, and then crossing the y-axis at -8. But let's do some testing of this. So I'm going to go ahead and I'm going to hit second trace, which is also the calc button. And I'm going to go look for it with zeros. All right. you see I need to find the left bound. And so I'm going to look at this particular one first to find the 0. I'm going to scroll up, and there's another video that shows you how to do this as well, but I'll just do this right inside and I won't go into as much explanation as I usually do, but you can look at the other video as well. And then, so I'm a little above the x-axis here, so I'm going to hit enter, and that changes it from left bound to right bound. I'm going to scroll down below the x-axis, which you can tell right here is negative 0.1809. I'm going to hit enter again, and now it's ready for a guess. And it's telling me that it's negative 2, 0 for one of my zeros, which that is one of the things that we guessed. So now what we're going to do is we're going to try the other 0. So second trace again. I'm going to hit 2, and I'm going to take the cursor to the right side. Now remember, when it says to the left, it's thinking from negative infinity to positive infinity. So you're going to start below the x-axis here. And then that's still at the left bound. I'm going to hit enter. Then I'm going to go a little above, and that's where the next one takes me up to 0.55. So that means now I'm going to do the right bound, and I'm going to hit enter. Now the calculator is ready to do a guess, and it has guessed at 40, and that is the other one that we guessed. Okay, so now let's go and find the minimum, and I say minimum because our vertex opens up, and when it opens up, we have a minimum. All right, so I'm going to go and I'm going to hit 3. And so I'm looking for this point down here, which we estimated would be at close to 1 on the x and negative 9 on the y. So let's test this out. We're going to go to a little to the left of where I think is center, because again, it's a left-bound question. So I think that's the bottom. So I'm going to go, okay, here's a little to the left. I'm going to hit enter. Then I'm going to go a little to the right, and you see when I do that, I hit enter again. Notice how you have these triangles up here that are facing each other. So it's guessing at the minimum somewhere in between. And then I'm going to hit enter because it's ready for a guess. And it is essentially 1, because that's how it's rounded. It would round to 1, and negative 9, which is also what we guessed. Okay? And I'm just going to use the trace button to figure out the y-intercept. So let's see what happens here. Let's get onto the graph. All right, oops, let me go back. Okay, and then I'm going to go a little to the left, to the left, to the left. You guys are probably too young to even know that. And my guess was 0, negative 8, and that's right where it's landing. So we don't even have to do, we could have done an intersect, but on this one it looked like it was going to hit right at negative 8, so I thought that was a good way to do it. So that ends the calculator part. Let's go back to the slide and calculate the zeros algebraically. So we did already show algebraically how to find the zeros, but one thing we did not touch on is the domain and range. So if you're taking a look at this graph, a domain, as it is always with a parabola, is negative infinity to positive infinity. So it's all real numbers. The range in this case, we've figured out what our minimum is. And so that means our range is negative 9 is the lowest y. And so it's less than or equal to y, which is less than infinity because it goes up to positive infinity. And that should answer all the questions for 1-122. Okay, for 1-123, they're asking us to graph each equation below and find the x and y intercepts. So because this particular first problem is already in slope-intercept form, our y-intercept is 0, 8. Okay, because that's where our y-intercept is at. Now, in order to solve for the x-intercept, we need to plug a 0 in for y. So I'm going to do that. And then solve for x. So the first thing I'm going to do is I'm going to give myself a little room because I know I'm doing something here. I'm going to do negative 8, because I'm subtracting each side, or 8 from each side, equals a negative 3/2 x. Well, then I'm going to multiply both sides by a negative 2/3 because that means I can cross out those particular fractions. But that means I also need to multiply this side by a negative 2/3, which means I'm going to have a 16/3 equals x. And so you can leave it as, I don't mind. I told students I didn't mind if you left it as 16/3, but some will want to put it in a mixed number, and that would be 5 1/3. Okay, so that means your x-intercept would be 5 1/3, 0. So those are, let me label that too. the 2 for that one. Now, when you go to part B is one of those that I really like as far as simplicity in finding x-intercepts and y-intercepts. First of all, to find the y-intercept, I'm going to plug a 0 in for the x, because this is in standard form, okay? And when it's in standard form, it's really easy to find the intercepts because you just put 0 in for x and then you put 0 in for y. So then I have minus 3y equals negative 6. I divide by negative 3 and y equals 2. So that means my y-intercept is 0, 2, which if you see the graph here, that's correct, okay? That's my y-intercept. All right, my x-intercept, I'm going to plug in 0 for y because y would have to be 0 if it's my x-intercept. So 2x minus 3 times 0 equals negative 6. So then 2x equals negative 6. We divide by 2. It equals negative 3. So that means my x-intercept is negative 3, 0. And if you look at the graph, it's at negative 3, 0. And that ends 1-123. Moving on. Okay, so for this particular problem, you'll notice I have all of these statements up here, but I'm going to solve them each one at a time. All right. I'm also going to be using this slope or point slope form of an equation because that's the easiest way to solve these. So I'm going to take this particular problem right now, and on part A, it's pretty simple because they've given us a point and they've given us the slope. So I'm just going to literally plug in y minus 8 equals our slope of negative 5 times x minus 2. Okay, so y minus 8, then we distribute the negative 5. And then we add 8. That's literally all you have to do for part A. Part B, however, you're going to need to calculate slope. So let's remind everybody what that is. It's y2 minus y1 equals, or over x2 minus x1 equals our slope. So this is our slope formula. So for part B and C, we're going to have to calculate our slope. So let's start with that first. I'm going to calculate it in a different color so we can break them up a little bit. So my y2 minus y1, so it'd be negative 4 minus 4 over 5 minus a negative 3. That equals negative 8 over a positive 8. So our slope is a negative 1. Okay, that's our slope. Part C, we're going to calculate the slope there as well. Part C, we would have negative 5 minus 4 over a 4 minus a negative 2. So it's going to be negative 9 over a positive 8. Oh, that's not a positive 8. What am I doing? Oh my gosh. My students in class would be laughing at me right now. That'd be a positive 6, which reduces to a negative 3 over 2. And that's your slope for the last one. Now, we're just going to go ahead and plug those into the equation. I can pick either of these points on part B to actually do this point slope form. So I'm just going to go ahead and pick, I'll just go ahead and pick the first point. So we've got y minus 4, because I'm using this point, equals our slope, which is negative 1 times x minus a negative 3. Okay, so y minus 4 equals a negative x, and that's going to be a plus 3 inside, so it's going to be a minus 3 when I multiply it. Then I'm going to add 4, and it's going to be a negative x plus 1. Okay, and that is part B. Now let's put the equation for negative 3 halves into this part C. And again, I'm just going to go ahead and pick the first one because it's there. And so I'm going to put y minus 4 equals negative 3 halves x, and then it's minus a negative 2. So I'm going to go ahead and just go ahead and plus 2. All right, y minus 4 equals negative 3 halves x. And if I multiply negative 3 halves times 2, I get a negative 6 over 2, which is a minus 3. Then I do the last thing, which is add 4. That's negative 3 halves x, and that's plus 1. And that is part C's answer. And that's all there is to 1-124. That point slope form of the equation is pretty powerful. So it's something I recommend using when you get a chance. And we'll talk to you in the next slide. Okay, these are pretty small, so I'm going to write them again down below. Okay, x plus 2 over 5 equals 10 minus 2x over 3. I love these because I like to do cross multiplication. Okay, so on this, I'm going to take that 3 and times plus x plus 2. And then I'm going to multiply the 5 times 10 minus 2x. I'm going to distribute, so it's 3x plus 6. And on the other side, it's going to be 50 minus 10x. Then we just solve. So I'm going to add 10x to the other side, so it'll be 13x plus 6 equals 50. Then I'm going to subtract 6, so that gives me 44. All right, so, oops, don't forget my x. Then I'm going to divide by 13, and x just equals 44 over 13, okay? And that's a fine way to leave it, so. All right, let's go to B. Okay, on B, let me go ahead and write this out as well. All right. This is not cross multiplication. We don't have two fractions. So, but I am going to go ahead and solve it. So the first thing I'm going to do is add 1 because I want to get that x term by itself. Then I want to get x out of the denominator. So I'm going to go ahead and multiply by x on both sides because that cancels it out here. So then 3 equals 9x. Well, then we divide by 9. And x equals 3 over 9, but that reduces to 1/3. So that's part B. Part C, looks like we've got ourselves a quadratic, but I'm going to write it out here because it's pretty small. First thing I'm going to do, since it's in quadratic form, is I'm going to move the 18 over and set it equal to 0. Okay. Then I'm going to use my lovely diamond method, which many of you have seen, and I could be going a little off the screen here, but I need two numbers that are going to multiply to a negative 18 and add up to 3. That will be 6 and negative 3, because 6 times negative 3 equals negative 18, and 6 plus negative 3 equals 3. So that means x plus 6 and x minus 3 are my factors. Now that means because if these were to equal 0, x would have to equal a negative 6 or x would have to equal 3. So those are the solutions for part C. And that's it for 1-125. All right, on both of these, we're supposed to solve for y. On the first one, we're going to use our angle-angle similarity. And I know that they're similar because we have an angle here that is shared between both, and they both have 90 degrees. All right, so that means I'm going to use the height from the smaller triangle, put it over the base of the smaller triangle. Then I'm going to set it equal to the height of the larger triangle over the base of the larger triangle. And then I'm just going to do the cross multiplication that I talked about earlier. So that means it's going to be 27, because it's going to be 3 times 9 equals 5y. So that's 27 equals 5y. We divide by 5. So y is going to be 27 over 5, or it could equal 5.4 if you're taking it down to the nearest tenth. But that is how you do part A. Part B is using SOHCAHTOA, which I've talked a little bit about too. Let me put that in ratio form. I actually like it better for students if you're getting confused. So sine is our opposite over hypotenuse. Cosine is our adjacent over our hypotenuse. And tangent is our opposite over our adjacent. So what I have to look at in this picture is, what do I have? Well, I have this angle measure. I have the opposite, and I have the hypotenuse. So I'm going to use sine. So that's the sine, which is opposite over hypotenuse. So I'm going to set that up. Sine of 15 degrees equals our y over 20. And then all I have to do is multiply both sides by 20. And so I get y equals 20 times the sine of 15 degrees. And that approximately, we say that because we have to round, so I'm going to do this little curly equal sign, equals approximately 5.2. Okay? And so that's your length for y on that one. All right, that ends 1-126. Okay, for this last problem on the closure activity, it says that Micah was given $200 and that every week he spends $15 on comics. Now, first off, I set up a graph. I wanted to see if I could figure this out graphically. And then we'll talk algebraically about how to find this specific x-intercept when we come back, because the x-intercept means he's run out of money. So we'll figure that out in just a moment. All right. First, I set the y-axis scale as total amount of money left from the 200 that he was given. The x-axis is labeled time in weeks. Well, that means I'm going to go ahead. I'm going to start with a point because I'm going to build a table. So I'm going to put on 0 week, he had $200. All right. Well, it goes down 15 each time. So I'm going to set up a little table here so we can kind of see these points plotted. So at week 1, after week 1, he will have 185 left. Then at week 2, we'll subtract another 15, and that's 170. Aren't you impressed with my math skills? It's so difficult. Just kidding. Week 3, it will go down to 155. And what I have forming on my right on this graph, it looks like it's linear, which makes sense because it is going down 15 each time. So I'm going to put one more point in, and that's 5, and at 125. All right. Now I have my y-intercept. I know that my slope is negative 15 because it's going downward. And so I want to draw a line to see where this goes. So I'm going to set up my y equals equation. So y equals, and my slope is negative 15, x. And then I started at 200. So I'm going to say plus 200. Okay. And you can see the graph. And it looks down here, it's going to end. He's going to run out of money sometime between week 13 and 14. And right here it says 13. So it looks like 13 and a third. So we're going to go prove that algebraically here as well. So our estimate is 13 and a third weeks. He will run out of money. Let's go see what it looks like when I'm writing it out. Okay, so we have our equation on the right. And we have our x-intercept, which we're pretty sure we know what's going on right in this area. So we're going to go ahead and prove that algebraically. So in order for it to be an x-intercept, for us to figure out what week Micah runs out of money, we need to plug a 0 in for the y, because that's what 0 would, or what y would equal if he ran out of money. So negative 15x plus 200. I'm going to subtract 200. I'm going to divide by 15, or negative 15. So negative 200 over negative 15 will equal 13 and a third, because you would end up with 200 over 15. And that is 13 and 1/3, or 13.33 repeating. Okay. All right. And that proves our point right there. And that ends the closure activity for chapter 1. And you will see me on my next video as we start a whole new unit. Thanks. Remember, if you like these videos, please subscribe or give me a thumbs up. And if you have any questions, please leave them in the comments section of the video at the bottom. Thanks so much. See you next video.